Welcome back to this third video of the short series of SimSolid videos focusing on AEC workflows. In the previous video, we looked at how we can generate connections and welds between our parts. And we're going to continue on this workflow by looking at setting up an analysis that will involve creating loads, boundary conditions, and more. So to start off this process, I'm going to go to the analysis option here. Under the drop-down list, we have a choice of a number of different types of analysis. Now I'm just using the basic SimSolid, but if we did have the advanced version, we would also have the grayed out option. So I haven't switched to that yet here. I'm going to go with the structural option. I'm going to click the structural linear analysis type here. And we can see it's added this selection to my project tree. And now I have all these different tools to facilitate my analysis. I'm going to zoom out and explain what my plans are with this. So I basically want to represent some continuity of this column by applying a fixed support at the top of my drum of the column here, and also at the bottom of this cross section, the wide flange. And it's quite easy to do. We're just going to use the immovable support option. So I'm going to left click. And within this dialog, we can choose how we want to apply this immovable support condition. I'm going to choose the face option since it is relevant to my application and it is quite easy to do as well. But you can see we can also fix an edge or a particular vertice or even a spot that we've created ourselves. So I'm just going to zoom into the top of this drum and select the face at the top. And you can see when I just left click on that face, it selects the entire cross-section face there. I can do the same thing on the bottom as well. So I zoom in to the bottom of this wide flange and I left click and it's now identified that face as well. And you can see I have both faces represented here. If I wanted to get rid of one, I can always delete it, or I can add more by simply clicking on more. But I'm going to be fine with this. So I'll just click the OK button. And we've created these immovable supports. And we have more to do now. So I'll zoom back out. And another item that I want to represent is my loading conditions. As you can see here, we have a number of different loads that we can apply to the model, and some of them may not necessarily all be relevant to our applications. I could obviously apply a pressure load or a specific force or displacement. So for example, if I knew that this beam was deflecting 2 millimeters downwards, I could apply that type of load and observe the resulting forces in the rest of the model. For this example, however, I'm going to go with a different approach, which is a remote load or displacement, where I actually have all the data within a CSV file. So here I can click on this imported remote load option. And I'm going to import this file that I'm pointing to right here. You can see the CSV file data that I'm importing. So it's just created a number of different loading conditions, 16 total rows of data, where I have the locations of all these remote loads, the forces, the moments, and so on. And I'll just click OK. And I'll be able to see those here. Let me just turn on the display of those loads. So we can see all those loads and where they're being applied. So they're being applied to the ends of the cross sections in the indicated directions. And the magnitudes we could see here, if I just right click, I can go to the edit menu and I can see all these magnitudes for each one of these loads as well. Now, of course, I can continue applying loads if I wanted to, for example, apply a point load to a specific location on my model. I could click on this force displacement button. And let's just say for the sake of this example here, I'm going to go with the single point load that I'm going to apply to just one spot in my wide flange, just for the sake of, I guess, variety here. I'll apply it to a face, and I'm going to apply it to this face here. And I'm just going to make it a fairly small value here with respect to the global coordinate system that I'm using, although it doesn't have to be with respect to that coordinate system. I'm going to make it a value of 100 newtons. I'll left click to apply, and here if I just display my loads again, you can see that it's 100 newtons that's been applied to that face. So at this point, we'd be ready to run an analysis. The only thing that I will set up is under the assembly option here, we can specify our materials. And I haven't done that yet, but I'll apply my material. And for the sake of this example, I'm just going to go with the generic steel material where we can see all the mechanical properties and so on that are being used. We can define our own materials. We can even import materials. For example, if we want to work with the Altair material database, we can also import data from there as well. More details are in the help system. If you just click on this, you'll be able to find more information. But I'm going to apply this steel material to all the parts in the assembly since that is relevant for this application. And in the next video, we're going to look at how we can actually proceed with the analysis and do some post-processing.